Now, we're going to do today, without graphing calculators. Can you use the graphing calculator? Absolutely. When you're doing your problems, when you're doing your tests, when you're doing your EOI, anything that is y equals can be put into the graphing calculator. As long as there's no y's on the right side, as long as it's like just a bunch of x's. Put it in the graphing calculator and take a look at it. But the reason that we want to do this today, even though it's parabolas, and parabolas can easily go in the calculator, is I want you to kind of learn some of the shifts. You know the parabola is the U shape. I want to kind of show you what the basic one looks like, how I can shift it left and right, how I can shift it up and down, and what those equations might look like. Because as things get more complicated, you'll need to know what makes things go left and right, and what makes things go up and down. Now, when you talk about the most basic thing, you're going to say parent graph. So when it comes to a parabola, it's parent. Like the most basic parabola is just y equals x squared. So y equals x squared is the most basic parabola. The reason is the vertex of this thing is on the origin right here at 0, 0. And then it does the regular U shape from here. All right, one thing we're going to do with a lot of different shapes. I told you about some shapes that are coming up after this. Circles, ellipses, hyperbolas. What we're going to do is take a parent and we're going to move it left and right and up and down. Yeah, Brian? What's an ellipse? Ellipse is like an oval. We're going to get there. We'll get circles first, and then we'll talk about how you kind of make them into ovals by stretching them.
That kind of hurt me.
Yeah. So that's where we're getting at. Circles are coming up next once we get there, probably next week. So here's our basic, our parent graph for a parabola, y equals x squared. What I want to do is, I want to take that U shape, take that parabola, and shift it up 2. So to shift it up 2, all I do is tack on a +2 on the right. And now you've just taken this, taken that parabola and shifted it up 2 spots. And so it's right here. And what's the vertex of this? 0, 2. 0, 2. Remember, coordinates are left, right, so don't go left, right, any, just go up 2. So if you want to shift if you want to shift a graph, if you want to shift a graph up or down, put a number out to the right. Just put a plus out to the right of it, and that'll shift it up. When I want to shift it down, I come over here and I put x squared minus 5. That just takes the u and shifts it to where the vertex goes down. 1, 2, 3, 4, 5. So we go down, maybe put a little 5 little tick marks. 1, 2, 3, 4, and then 5. 5. Now what's the vertex of this guy? 0, negative 5.
Good job. Thank you.
All right, there's your most basic shift. Shifting things up and down, really easy. How do we do it?
Tack on a plus or a minus and a number at the end.
At the far right of your equation, if you would just tack on a plus or a minus, that will shift whatever it was, whether it's a parabola, ellipse, parabola, circle, ellipse, parabola, any of the shapes you're getting ready to see. That's how you shift them up and down. Now, when it comes to left and right, the left and right shifts, so we start with this. Here's your parent right here. Instead of tacking a number on, what I'm going to do is change, I'm going to turn x into a parenthesis and put a number inside the parenthesis with x. That's a left-right shift. So there's my parent. If I want to shift left to right, I'm going to change that x squared to x minus 4 squared. The one thing, though, is that this left-right shift is always going to be opposite what you might think at first. A negative 4 does not go left. Inside the parenthesis, negative 4 will actually shift it to the right. So what you do is take your parent parabola, shift it right 4. 1, 2, 3, 4, and there it is. So there's our right shift by 4. And what's our vertex of this guy? Right 4? So 4, comma 0.
40.
4, 0. And then we're going to go to the left. So a number inside shifts you left, but not the direction you would think at first. This is shifting left by 2. And the vertex of this guy is what? Negative 2 and 0. So I'm going to zoom out on those 4. So, 2 things. Up and down shifts. Very easy. What shifts any graph up and down?
Plus and minus at the far right end of it.
Plus or minus at the end of it. Up and down. If it's plus, you go up. If it's minus, you go down. It's pretty easy. What shifts something left or right?
Parentheses and square.
Parentheses. Yeah, and change your x squares to a parentheses squared. And then whatever number is in the parentheses, how do you know what direction to go?
Negative. Negative goes positive.
Yeah, negative goes right. Positive goes left. So there's your up-down shifts and your left-right shifts. All right, let's look on the back side. So what we just said, let's put it in here. A number outside the parentheses, number on the far right, outside the parentheses, does what?
Up and down.
Up and down, up or down. That is your up or down number. Inside will do you left or right, but always shift opposite the left or right on the inside of the parentheses, but always shift opposite. This is opposite the sign. So negatives get you right, positive go you left.
Shift up over.
Yep. All right, here's a new thing. It's a flip. Now you know you've seen upside down parabolas. So this is, if you took the parent graph, which is the U, and just stuck a negative in front of it, all of a sudden it just flips it upside down. Makes this like sad upside down parabola. Just like that. So a negative sign will flip the picture. It flips it over the x-axis. So a negative sign means flip. So if somebody puts a negative in front of the x squared, or a negative in front of a parenthesis with the x in it, that's going to flip it down. So it's sad, and it's down here. And then example 6 and 7 together. Hunter did mention this yesterday when we had that fraction. When we said like we had the fraction, what did that do with the u?
Up one or make it
Wider.
Wider. A fraction like this, like any fraction less than 1 is going to make it wider. Any number bigger than 1, like 2, 3, 4, 5, makes it skinnier. So that's what the numbers and the coefficients do. This is skinnier, just make a little skinnier u, and then make a wider u.
I can make it one anyway.
Skinny and wide. So a number in front is going to just change the shape. Just put it changes the shape. Understand that numbers, 2, 3, 4, 5, 6, 7, 8, 9, make it very, 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 very skinny. The bigger, the skinnier. And then fractions between 0 and 1, 1/2, 1/4, 1/3, make it wider. So it changes the shape. A number in front just changes the shape. Call it skinny or wide. Fractions go wide, numbers go skinny. Just knowing that, a lot of times when you're looking at, if you looked at 9x squared, and there's only one really skinny parabola, it's going to be that one. And now these last two, we're doing two right here that have a combo of everything. So here's our combo. And I want to list out everything that's happening. So let's start with the first thing we learned. This plus 3 out of there on the far right. What's it going to do with your u?
Up 3.
We're going to go, it's going to start up 3. Up 3. So I might come here and put 3 tick marks. This -2, that's your left-right shift, but -2 takes you what direction?
To the right.
To the right. So your vertex has moved up 3 and right 2. So go this way, up 3 and right 2, and you can, now that you know that's the vertex, go ahead and put it out there for the vertex. The only other thing is that 5, what do we say about 5 out here? The coefficient in front,
It's going to make it skinnier.
it's going to make it skinnier. Now, are we flipping this thing? No, it's not negative. So from here, from the vertex, just make a skinny parabola right there. The 5 makes it skinnier.
How much skinny?
I mean, this is just kind of a judgment call. 5 is a decent skinniness. 2, 3, 4, 5. When it gets like anything bigger than 5, really skinny. That's skinny. So my vertex, though, the biggest thing is my vertex is going to be 2, 3. Right 2 and up 3. 2, 3. Right 2, up 3. That's my vertex. So understand how shapes move. The number outside made us go up. The number inside made us go right, even though it's a negative. That just made us skinnier. And let's do this combo right here. Take a second, make sure you got all that in there. We got our last example. I see a negative, I see a fraction, I see some left-right shift, some up-down shift. Okay, let's go with, we got our U, start right here. What's that 5 do for us? So from the parent graph, we went up 5. What's this one do for us?
Left.
Left 4. I'll just put L4. So I'm gonna put those tick marks. I'm gonna go 5 this way, and 4 that way. The vertex is left 4 up 5 right here.
Doesn't
Now,
matter.
yeah, now 2 things happening right here. The negative does what?
Makes it wider.
Flips down, so it's sad, and then the 1/3 does what? It's wider, so it's sad and it's wider, and go. So do an upside down one.
It's a stress eater.
And tell me what the vertex is right here. Vertex. -4.
-4, 5.
Positive. -4, positive. -4, positive. 5. Okay, sum it all up. Numbers on the far outside move you where? Up or down. Numbers inside the parenthesis move you,
Left or right?
but opposite. If I have a coefficient, what does it do?
Tell us how wide or skinny.
Wide or skinny. Fractions are what?
Wide.
Wide. Big numbers are
Skinny.
skinny. And then a negative in front,
Flips it upside down.
flips it upside down. We kind of already knew that one. That's everything about basic shifts. All of those things are going to apply when you start learning about circles, ellipses, and hyperbolas.